In this video, you will learn about simplifying radical expressions with variables. First, let's see what happens when I simplify radicals of variables by using what I know about numbers. So for example, the square root of 5 squared becomes just 5, because the square root and the square undo one another. So if I were to apply this with x squared, I can automatically assume that the square root of x squared becomes just x. Now for x to the third, I can separate x to the third to be x squared times x, which becomes the square root of x squared times the square root of x. And when I simplify the square root of x squared, I get x. So your answer is x times root x. Now for x to the fourth, I can separate x to the fourth to x squared times x squared. So I split the square root, and then when I simplify, both square roots of x squared becomes just x times x, which becomes your final answer of x squared. For x to the fifth, I can separate that to become x squared times x, and I separate the square roots, and then we know that both square roots of x squared becomes x, so it's x times radical x, and we know that x times x is x squared, so your final answer is x squared x. For x to the sixth, I can separate it so it becomes square root of x squared times square root of x squared times square root of x squared, and separate the radicals like here. All those square roots become just x. We know that x times x becomes x to the third. And then lastly, x to the seventh can be written as square root of x squared times x squared times x squared times x. I can separate those radicals. Each of those x squareds become just x. So your final answer is x to the third x. So what I can see from looking at just the answers, we can see a pattern in what happens. Essentially what we're doing is dividing by 2, and then whatever your remainder is left outside. So what we can use from this pattern is we can say that for each of these, you take the exponent, divide it by 2, the remainder stays in the radical. So for example, if I were to do 7 divided by 2, gives you 3, because 2 goes in evenly 3 times, with a remainder of 1. Hence why the 3 becomes inside, and the 1 is the exponent inside the radical. So when you want to separate radicals of variables, you want to first separate the number and variable into separate radicals, simplify the radical expression for the number and the variable separately, and then combine the radicals together, multiplying the radicals outside together and the ones inside the radicals together. So for these two examples, first radical 72, I'm going to split into two radicals, so I have the square root of 72 and the square root of x to the fourth. If I want to simplify the square root of 72, I have to identify the biggest perfect square divides evenly, which in this case would be 36. So it's 36 times 2. And if I separate that square root, I get square root of 36 times the square root of 2. And the square root of 36 is 6 root 2. For the x to the fourth part, I know that 4 divided by 2 equals 2, or the remainder of 0. So if x to the fourth is just going to become x squared. So this is times x squared. So if I put this all together and keep the parts that are outside together, so 6x squared stay outside, and then you're left with radical 2. For 28, n to the third, I can separate it, so I have radical 28 times radical n to the third. If I separate the radical 28, the biggest perfect square divides is 4, so it's 4 times 7, so it's radical 4 times radical 7, so it becomes 2 root 7. And then for the variable part, if I do 3 divided by 2, 2 goes in evenly with a remainder of 1. So this becomes n, radical n, So it's times n radical n times n radical n. And then what I'm going to do is the last part is the numbers that are outside go together. So I'm going to get 2n, and then the parts inside go together. So it's radical 7n. And those will be your final answers. So for the next example, I'm going to do the same thing. So I separate my radical. So I have radical 180 from radical n squared. Then I find the biggest perfect square divides into 180, which is 36. So it becomes the square root of 36 times 5. So it's the square root of 36, the square root of 5, and the square root of 36 is 6. So it becomes 6 root 5. For n squared, the x1 is 2. So I do 2 divided by 2, which gives you 1 with a remainder of 0. So n squared becomes just n. So now I'm going to put it back together, so the parts that are outside go together. So it becomes 6n. And then the parts inside is only 5, so it's 6n radical 5. For the other example, I again separate it. So it becomes radical 12 times radical x. Biggest perfect square divides into 12 is 4. So it becomes 4 times 3. So it's radical 4 times radical 3, which gives you 2 root 3. And for radical x, there's a coefficient, or an x1 of 1. And 1 divided by 2 is 0, remainder 1. So it's just going to stay as 1x inside. So it just stays as radical x times radical x times radical x. So your final answer is the two parts, or the only part outside. This technically has a 1. So 2 times 1 is 2. And the parts inside go together, so it's 3 and x. So it's radical 3x. So your final answer would be 2 radical 3x. For this example, now what I'm going to do is I'm going to keep the negative 5 separate, and then I'm going to separate the inside as well. So I'll have negative 5 times radical 75 times x to the 4th. Now for the radical 75, the biggest perfect square divides is 25, so it becomes 25 times 3. So it's radical 25 times radical 3, which gives you 5 radical 3. For the variable, I can divide 4 by 2, so 4 divided by 2 gives you 2, the remainder of 0. So the square root of x to the 4th becomes just x squared. So this is times x squared. And then a negative 5 is just carried down as well. So now I'm going to multiply all the parts outside together. So negative 5 times x squared. This gives you negative 25 x squared with a radical 3 left inside. So your answer is negative 25x squared, radical 3. And for my final example, I now have two variables, but I'm going to follow the same process. So I get square root of 16 times the square root of x to the 3rd times the square root of y to the 4th. 16 is actually a special case because it's a perfect square. So square root of 16 is 4. X to the 3rd, if I do 3 divided by 2, gives you 1 with a remainder of 1. So x to the 3rd becomes x root x. So I have 1x outside and 1x inside. And then y to the 4th, do 4 divided by 2, which gives you 2 with a remainder of 0. So this becomes just times y squared. So when I put all back together, I take the parts that are outside, so x, 4, and y squared. So I get 4x, y squared, and then the only thing in the radical is square root of x. So your final answer is 4x y squared, radical x.